2017 National Electrical Code, or NEC, does not mandate using only plastic strain reliefs with plastic enclosures. A strain relief, as defined in Article 100 of the NEC, is a fitting designed to prevent stress on conductors where they enter equipment. Plastic strain reliefs are frequently chosen for plastic enclosures because they don't need a ground connection and are less likely to damage the enclosure compared to metal ones. However, metal strain reliefs are permissible with plastic enclosures if they are correctly grounded. The 2017 NEC stipulates that all non-current carrying metal parts of equipment accessible to personnel must be grounded. This includes metal strain reliefs. To ground a metal strain relief properly, it must be connected to the building or structure's grounding system. If a damaged cord exposes a conductor to a metal strain relief, the energized metal part could present a safety hazard. But this risk is reduced if the metal strain relief is properly grounded. The grounding system offers a path for current to flow to the ground, preventing the metal strain relief from becoming energized. Generally, plastic strain reliefs are preferable for plastic enclosures. However, metal strain reliefs can be used if grounded correctly. Grounding ensures a safe path for fault current, minimizing electrical shock hazards. Proper grounding involves connecting the metal strain relief to the building's grounding electrode system, ensuring a low impedance path for fault current. This connection should comply with NEC requirements for grounding conductor size and installation methods. When using metal strain reliefs in plastic enclosures, ensure the enclosure provides adequate space and support for the strain relief and its grounding connection. Avoid over-tightening strain relief connectors, as this can damage the enclosure or conductors. Regularly inspect strain reliefs for damage, corrosion, or loose connections. Replace damaged or deteriorated strain reliefs promptly to maintain electrical safety. Consider the environmental conditions when selecting strain relief materials. In corrosive environments, use strain reliefs made of corrosion-resistant materials. Select strain reliefs that are appropriately rated for the voltage and current of the conductors they protect. Use strain reliefs that are listed and labeled by a recognized testing laboratory. This ensures they meet applicable safety standards. Follow manufacturer's instructions for installing strain reliefs. Proper installation is crucial for ensuring their effectiveness and safety. Conductors should be properly sized and insulated for the application. Overloaded or poorly insulated conductors can create a fire hazard. Use appropriate wiring methods for the environment. Exposed wiring can be easily damaged and create a safety hazard. Electrical equipment should be properly maintained. Regular maintenance can help prevent electrical problems and ensure safety. Be aware of the potential hazards of electricity. Electricity can be dangerous if not handled properly. Always follow safety precautions when working with electricity. Consider using ground fault circuit interrupters, known as GFCIs, in areas where there is a risk of electrical shock. GFCIs can quickly interrupt the flow of electricity in the event of a ground fault, preventing serious injury. Use arc fault circuit interrupters, known as FCIs, to protect against electrical fires. FCIs can detect arc faults, which are a common cause of electrical fires, and quickly interrupt the flow of electricity. Ensure that all electrical work is performed by a qualified electrician. A qualified electrician has the training and experience to perform electrical work safely and correctly. Follow all applicable electrical codes and regulations. Electrical codes and regulations are designed to protect people and property from electrical hazards. If you are not comfortable working with electricity, do not attempt to do it yourself. Hire a qualified electrician to do the work for you. Remember to turn off the power before working on any electrical equipment. This will help prevent electrical shock. Use insulated tools when working on electrical equipment. Insulated tools will help protect you from electrical shock. Wear safety glasses when working on electrical equipment. Safety glasses will help protect your eyes from flying debris. Do not work on electrical equipment in wet conditions. Water can conduct electricity and create a shock hazard. Be careful when working near power lines. Power lines can carry high voltage electricity and can be deadly. Call the utility company if you need to work near power lines. They can energize the power lines or provide other safety precautions. If you see a downed power line, stay away from it and call the utility company immediately. Downed power lines can be extremely dangerous. Educate yourself about electrical safety. The more you know about electricity, the safer you will be. Remember, safety first when working with electricity. The NEC provides detailed guidelines on grounding and bonding, crucial for electrical safety. Grounding creates a low impedance path for fault currents, facilitating the operation of overcurrent protective devices like circuit breakers and fuses. Bonding connects non-current carrying metal parts to create an electrically conductive path, minimizing voltage differences and shock hazards. When using metal strain reliefs and plastic enclosures, ensure proper bonding between the strain relief and the equipment grounding conductor. This connection should be mechanically sound and electrically continuous. Consider using grounding bushings or lugs to facilitate the bonding connection. These devices provide a secure and reliable connection point for the grounding conductor. Inspect grounding and bonding connections regularly to ensure they are tight and free from corrosion. Loose or corroded connections can increase impedance and reduce the effectiveness of the grounding system. Use appropriate tools and techniques for making grounding and bonding connections. Improperly installed connections can be a safety hazard. Refer to the NEC for specific requirements on grounding and bonding conductor size, material, and installation methods. The NEC provides detailed tables and calculations for determining the appropriate grounding conductor size based on the size of the circuit conductors. When working with electrical systems, always follow lockout/tagout procedures to de-energize the equipment before starting work. Lockout/tagout procedures prevent accidental energization of the equipment, which can cause serious injury or death. Use appropriate personal protective equipment, or PPE, when working with electrical systems. PPE can help protect you from electrical shock, burns, and other hazards. Examples of PPE include safety glasses, gloves, and insulated footwear. Be aware of the potential hazards of working with electricity and take steps to mitigate those hazards. Electricity can be dangerous if not handled properly. Always follow safety precautions and use common sense when working with electrical systems. Proper strain relief is crucial for maintaining the integrity of electrical connections and preventing damage to conductors. Strain reliefs protect conductors from stress, strain, and abrasion, which can lead to insulation damage, short circuits, and electrical fires. When selecting strain reliefs, consider the type of cable or cord being used, the environmental conditions, and the mechanical stresses the strain relief will be subjected to. Use strain reliefs that are appropriately sized for the cable or cord being used. Oversized strain reliefs may not provide adequate support, while undersized strain reliefs may damage the cable or cord. Select strain reliefs made of materials that are compatible with the cable or cord insulation and the environmental conditions. Some materials may degrade or become brittle when exposed to certain chemicals or UV radiation. Install strain reliefs according to the manufacturer's instructions. Proper installation is crucial for ensuring their effectiveness and safety. Regularly inspect strain reliefs for damage, wear, or loose connections. Replace damaged or deteriorated strain reliefs promptly to maintain electrical safety. In addition to providing strain relief, some strain reliefs also provide environmental protection, such as sealing against moisture or dust. Consider using strain reliefs with environmental protection features in harsh environments. When using cord grips or cable glands, ensure they are properly tightened to provide a secure seal and prevent the ingress of moisture or contaminants. Avoid over-tightening cord grips or cable glands, as this can damage the cable or cord. Use appropriate lubricants or sealants when installing cord grips or cable glands to ensure a proper seal. Choose strain reliefs that are easy to install and maintain. This can save time and effort in the long run. Consider using strain reliefs with quick connect or snap fit features for easy installation. When replacing strain reliefs, use the same type and size as the original strain relief. Using a different type or size of strain relief may compromise the safety and performance of the electrical connection. Keep a supply of spare strain reliefs on hand for quick replacements. This can help minimize downtime in the event of a strain relief failure. Proper planning and selection of strain reliefs can help ensure the safety and reliability of electrical connections. It is essential to consider the specific application requirements and choose strain reliefs that are appropriate for the task. By following these guidelines, you can help prevent electrical hazards and maintain a safe working environment. Grounding and bonding are essential safety measures in electrical systems. They help to protect people from electrical shock and prevent damage to equipment. When working with electrical systems, it is important to understand the principles of grounding and bonding and to follow all applicable codes and regulations. Use appropriate grounding and bonding techniques for the specific application. There are different grounding and bonding methods for different types of equipment and systems. Ensure that all grounding and bonding connections are properly made and maintained. Loose or corroded connections can increase resistance and reduce the effectiveness of the grounding system. Regularly inspect grounding and bonding connections for damage or corrosion. Replace any damaged or corroded connections immediately. If you are not sure how to properly ground and bond an electrical system, consult with a qualified electrician. A qualified electrician can help you design and install a grounding system that meets all applicable codes and regulations. Remember, grounding and bonding are essential for electrical safety. By following these guidelines, you can help protect yourself and others from electrical hazards. Consider the specific application when selecting strain reliefs. Factors to consider include the type of cable, the environment, and the mechanical stresses the strain relief will be subjected to. Use strain reliefs that are listed and labeled by a recognized testing laboratory. Listed and labeled strain reliefs have been tested to meet safety standards. Install strain reliefs according to the manufacturer's instructions. Improper installation can compromise the safety and performance of the strain relief. Regularly inspect strain reliefs for damage or wear. Replace damaged or worn strain reliefs promptly. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which can help to prevent electrical shock. Bond all metal parts of the electrical system together. Bonding helps to create a low impedance path for fault current. Use appropriate grounding and bonding conductors. The size of the grounding and bonding conductors should be appropriate for the size of the circuit. Inspect grounding and bonding connections regularly. Loose or corroded connections can increase resistance and reduce the effectiveness of the grounding system. Follow all applicable electrical codes and regulations. Electrical codes and regulations are designed to protect people and property from electrical hazards. By following these guidelines, you can help to ensure the safety of electrical systems. Also understand the purpose of a strain relief. It is to prevent mechanical stress from being transmitted to the electrical connections inside the enclosure. This stress could be from pulling, twisting, or bending the cable. By absorbing these forces, the strain relief protects the conductors and terminations, preventing them from loosening or breaking. When choosing a strain relief, consider the environment in which it will be used. For example, if the enclosure will be exposed to moisture, choose a strain relief that is rated for wet locations. If the enclosure will be exposed to corrosive chemicals, choose a strain relief that is made of a corrosion-resistant material. There are two main types of strain reliefs: non-metallic and metallic. Non-metallic strain reliefs are typically made of plastic or nylon. They are a good choice for applications where there is no need for grounding. Metallic strain reliefs are typically made of metal, such as steel or aluminum. They are a good choice for applications where grounding is required. When installing a strain relief, it is important to follow the manufacturer's instructions. The strain relief should be properly sized for the cable being used. It should also be tightened properly to ensure a secure connection. Periodically inspect strain reliefs to ensure that they are in good condition. Replace any strain reliefs that are damaged or worn. When working with electrical equipment, always follow safe work practices. Wear appropriate personal protective equipment, such as safety glasses and gloves. They energize the circuit before working on it. If you are not comfortable working with electrical equipment, contact a qualified electrician. The choice between plastic and metal strain reliefs often depends on the specific application and local electrical codes. Metal strain reliefs, when properly grounded, can offer enhanced mechanical protection and may be required in certain industrial or hazardous locations. However, in situations where grounding is not feasible or required, plastic strain reliefs provide a safe and effective alternative. Remember to always consult the latest edition of the NEC and local amendments to ensure compliance with all applicable regulations. Proper installation and maintenance are key to ensuring the safety and reliability of electrical systems.